going to talk about heating, ventilation, and air conditioning, or HVAC, on your vehicle. First thing we'll talk about is the heater core. The heat coming from your heater is hot coolant coming from your engine. So it takes your engine running to create that heat. And when your engine's cold, you're simply not going to have any heat. The heater core is simply a small radiator that's in your dashboard. Here's the general airflow and some of the controls that we have here. Blower motor moves the air through, and of course we can usually change the speed of that. Then we've got a couple of doors here that can direct the airflow either through the heater core or around it. And then we've got some mode doors that can change where the air is blowing out at, whether it's coming through the dash vents at our face or through the defrost or the floor. Here's an example of the inside of a heater box. This one, the blower motor has been removed. It's sitting up here in the background, but the scroll right here is where the blower motor moves air. And this door right here is the temperature blend door that changes how much air is allowed through the heater core. When it's down in this position, all of the air blows through the heater. If it is swung to the up position, all of the air is directed around the heater core. Something important here is this little foam rubber pad that's sealing the heater core right here against the side of the box. When your car starts to get older, like 20, 30, 40 years old, this foam rubber will break down just through age, wear and tear. If that happens, air can sneak around the side of the heater core and your heater won't be as effective. You might also get some whistling, maybe even chunks of rubber blowing in your face. I'm going to talk about the controls. This door right here could be operated by a cable, a vacuum servo, or an electrical servo. Most cars these days, most of the cars you have, they use electrical servos that allow very precise control of these doors. We'll talk about cables and vacuums next. These valves are coolant control valves. These are placed in line on the heater hoses going to the core and allow you to shut off the flow of coolant going into the heater core. This is important if you're requesting maximum air conditioning. This one on top is controlled by a vacuum. There's this little tube, and the one on bottom is controlled by a cable going to the knob that's on your dashboard. Here's one failure mode of a heater core. They can either leak or they can get plugged up. If they're leaking, you have to replace them. There's really no one out there that repairs a leaking heater core anymore. I don't recommend using a sealer in your cooling system because it could do this right here. It could seal up the passages in your heater core. This one appears that it was plugged up, and instead of flushing it out, they opted to replace it. Now, if your heater core is leaking, again, you have to replace it. If it's just plugged up, chances are you could flush it out. Here's an example. These heater hoses were removed from the heater pipes. Water from a garden hose was flushed through, and on this first example, you see it's kind of clear water. Then they switched to the other side to back flush it, and we get all this gunk out of there. They kept flushing it until that ran clear, and what you do is you go back and forth on the left and right, inlet, outlet, until it's nice and clear. Then you hook your hoses back up, top off your coolant, and then your heater core should work again. Air conditioning is a heat remover. It doesn't make cold air, it just gets the heat energy out of your cabin. By now you've probably watched the Donut Media video that explains quite a bit of detail on air conditioning systems, so I won't go into it too much here. This is just a quick review. The refrigerant in your air conditioning system is in a closed loop. Compressor pressurizes it. It goes through the condenser, which is usually at the front of your vehicle, looks kind of like a radiator. It turns from a gas into a liquid. That high pressure liquid goes through an expansion device, is allowed to expand into a vapor where it picks up a lot of heat energy from the passenger compartment of your vehicle. Then it returns to the compressor and the cycle keeps going over and over again. Two different types of systems. I don't know if they talked about in the Donut Media video is orifice tube and expansion valve. And an orifice tube, you've got this little brass straw inside this replaceable orifice tube assembly that is your expansion device. Your compressor is building pressure, turning that pressurized gas into a pressurized liquid. Then when that liquid flows through the orifice tube, it's allowed to expand back into a cooled off gas where it can absorb heat in the passenger compartment. Orifice tube doesn't have any moving parts. So this type of system requires that the air conditioning compressor is cycled on and off. And on vehicles like this, you can hear it kicking on and off typically. Here's some more detail on the orifice tubes. Note that these three are color coded. That represents the diameter inside this brass straw. If you have a four-door vehicle, it might require a different diameter orifice tube than a two-door vehicle would, just because of the volume of the passenger compartment. So those can often be changed out on these types of systems to fine-tune how the air conditioning performs. The other type of system is the expansion valve system. This reacts to the temperature of the evaporator. That's the part of the AC that's in your dashboard. If the evaporator is hot, the expansion valve opens, allowing refrigerant to flow. When the evaporator gets cold, the expansion valve shuts down, reducing the amount of refrigerant flowing through. On these type of systems, the compressor can still cycle on and off, but doesn't need to cycle as much. There's some more detail about that expansion valve. Again, when the dash is cold, the expansion valve closes down. When the dash is hot, the expansion valve opens up. For AC compressors that need to cycle, we usually have a clutch on the front of the pulley. This pulley will have a belt coming from the crankshaft of the engine. Oftentimes, it's the same belt as your alternator, power steering, and all those other accessories on the front of an engine. So when the engine's running, this pulley needs to be able to turn. If you don't need air conditioning, this clutch right here disengages from the pulley and allows the compressor shaft to stop turning. When you request air conditioning, an electromagnet inside of the pulley pulls on this clutch disc and engaging the pulley and locking them together so that when the pulley is turning, the compressor shaft turns as well. This clutch, like any other clutch, can wear out. I'm gonna talk through a couple different modes that we could set our heater to. On this slide, we've got fresh air coming in, full heat, blowing defrost in the side window. So fresh air is coming from right below our windshield into the fan. The fan is blowing it into the heater box. This evaporator core is the AC component that's in your heater box. Notice that all of the air going from the fan is all flowing through the heater core. The first door that we have here is the temperature blend door. This is fully open to allow all of the air to flow through the heater core. The air is flowing through the evaporator core because the evaporator is going to get cold, and that coldness will condense any moisture that's coming in from the outside air. When we condense that, we can drip the moisture away to the exterior of the vehicle. Then we have dry air going through the heater core. When it's dry and warm, it defrosts our windows much quicker than if it was humid and hot. That would just be blowing more steam on our already fogged up windows. So the air flows on and it hits a couple of other mode doors. This mode door for the floor is closed off, so air is not flowing that way. Here's another one for the panel. These are the vents aimed at your face. This one's closed off as well. So all of the air flowing through is getting dried out, heated, and then blowing on your windshield and the side windows so that you can see out your mirrors. In the next mode, our temperature is still the same. We're still flowing air from outside, drying it, heating it, and now we've split the mode. So some of the air is blowing on the windshield and some is blowing down on our floor. This is important on a rainy day. This is the air that dries out our carpet and our feet. Think about how heat rises. If all of our heat was just going to the windshield, it would go up the windshield and over your head. If you're cold, you need that hot air to come underneath the dashboard and flow past you to warm you up. So this is what the mode doors are doing when you're asking for heat and you want to be warmed up as well. Here we've changed the temperature blend door a little bit. This would be an example of, okay, you're getting nice and warm, your windshield is defrosted, you're turning the temperature down a little bit. This blend door will split the difference. So some of the air is still flowing through the heater core and the rest of it is blowing around the heater core so that the overall average temperature is a little bit cooler. If we ask for maximum air conditioning, we maybe don't want the hot air that's outside. So our recirculation door is going to close off the outside air and draw air from the inside. Typically, this door is positioned that defaults to allow fresh air from outside. That way we keep getting oxygen to breathe. Now, when it closes off, it's taking the air from inside the passenger compartment and passing that back through the system. It's going through the blower motor, through the evaporator core to be dried out and chilled. And then the temperature blend door is completely closed off, bypassing all the air around the heater core. On the valves that I showed you earlier, we might also shut off the coolant flow through the heater core to prevent any heat from entering the heater box here. Our first mode door, we've shut off airflow to the floor. We've also shut off airflow to the windshield. We've got a little bit blowing on the side windows just to keep them clear. And then the rest, most of the air is blowing through the dashboard at our faces. The refrigerant that is in an air conditioning system is designed to operate at a certain pressure range. Since it needs to transfer from a liquid state to a gaseous state, it needs to be in a sweet spot. If there's not enough pressure, it'll never condense into a liquid. If it's too much pressure, there's no room for it to expand into a gas and it can't function properly. If you're working on the lab sheet right now, an important thing to note is that around 70 degrees Fahrenheit, the pressure in our system should be around 71, just above 70 psi of pressure. This is if the car is parked and it's a 70-degree day and every single piece of the car inside and out is 70 degrees, that's how much pressure we should expect to see. Notice, as it gets warmer, we see more pressure because it's a closed system. It wants to expand when it gets hot. If we're checking a car out and we suspect something wrong with the air conditioning system, the first thing we're going to do is look at the static pressure of the vehicle before we turn the car on and start using the air conditioning system. If we hook up our manifold gauges to it and it's 70 degrees outside, and both of these needles are pointed at 100 psi, both the suction side and the discharge side of the compressor at the same, because the car's not on. If they're both at 100 psi, that's too much. There's too much refrigerant in this car and it's not able to expand properly. If it can't expand right, it's not going to absorb heat energy in your dashboard to move it out. Here's the other end of that spectrum. Same car, 70 degrees outside, everything on the car is 70 degrees, but now our pressure is too low. If it's too low, the compressor can't condense it into a liquid to get the heat energy out of it. So it might absorb heat in the passenger compartment, but it can't get rid of the heat on the engine compartment of the car. This car needs more refrigerant. Cabin filters. Almost all of your cars have some form of cabin filter, unless it's a very old car. Have you ever changed the cabin filter of your car? Do you know where it's at? I have a few examples of some really gross cabin air filters that sat in cars for more than 10 years, and they are absolutely disgusting. Let me know if you want to see them. Intake vents. So when I was showing you the diagrams of airflow through the heater box, most of the time the air was coming from outside of your vehicle. This is the base of your windshield. You see the wipers here? These holes right here are the vents where air enters the heater box of your car. See all this nasty leaves and needles here? That's literally the air you breathe. This is the air that touches your face. If you open the hood of your car and you see these vents packed full of debris like this, please clean it out. Again, that's the air you are breathing. Time for lab.